Today's lesson is how to multiply with decimals. Well, first of all, we need to remember that decimals are part of a whole. So just watch this one and then I'll have you guys use your own 10 by 10 grids, but this one is just to watch. Let's imagine that this 10 by 10 grid represents one whole. So this is 10 tenths. And each of these little boxes would be 1/100th, or like a penny. So this is like $1. A row would be like a dime, a tenth, and a box would be like a penny, 1/100th. So let's say that we've got one whole. So that's 10 tenths. And let's say that we wanted to take 6/10 of that one whole. 6/10 of one whole. What we could do to visually represent that would be to take 6/10 of that one whole. And then we can see where the colors overlap. Now with your colored pencils, this is going to be even cooler because you know from art that blue and yellow makes green. So we could count up all the boxes that overlapped, which is all of these. And we can figure out that 6/10 of one whole, or 6/10 of 10 tenths, equals 6/10, because anything times 1 equals itself. Okay, so what if we did something a little bit different? What if we wanted 6/10 of 2 wholes? Well, if 6/10 of one whole is 6/10, then that would mean that if we're doubling the amount that we have, because we're multiplying now by 2, we would have 12/10. So we could say that if 6/10 of one whole equals 6/10, then 6/10 of 2 wholes would equal 12/10. That's an improper fraction. We need to simplify that. If we're thinking about it in terms of decimal form, it would be 1 and 2/10. We could also go back and we could simplify this even more and say that's the same as 1 1/5. But if we were just going to write it as a decimal, we would write 1 and 2/10. So multiplying with decimals can be a little bit wonky or a little bit counterintuitive if we've been taught whenever you multiply you get bigger and bigger and bigger. Well, not necessarily. If your groups aren't even one whole size and they are 6/10 size, then maybe not. 6/10 of 2 wholes is going to be less than 2 wholes because it's 6/10 of one whole plus 6/10 of another whole. Let's look at it another way. Okay, get your grid paper out, your 10 by 10 grid, and choose 2 colored pencils that are primary colors. Think to art. Primary colors, red, blue, yellow. You can choose 2 of them because the cool thing is that where they overlap, you'll get a secondary color like orange, green, or purple. I'm going to use blue for my first color. Feel free to use blue as well or a different color of your choice. Just don't use yellow. So I'm going to use blue and yellow. For this first color, feel free to use anything except for yellow. Okay, here we go. So I'm going to draw 5/10 by coloring in 5 of these tenths strips. There's 4, there's 5. 5/10 is the same as a half, 1/2. So when you look at it, half of your grid should be colored. Write this down. Okay, now if we wanted to take 6/10 of 5/10. That means 6/10 of what we have to start with. Now what we're starting with is not even one whole. And now we're going to take 6/10 of it. So get your other color that you've chosen. Mine happens to be yellow. And going the opposite direction, color in 6/10. Now, what this means is that we're starting with a group that's only 1/2, like half of a brownie pan, and then we're taking 6/10 of that 1/2. So we need to think this is 6/10 of 5/10. Well, wherever we have overlapping is going to be where our answer is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so 30 of them. But 30 what? Well, 30 of these little squares. But what are each of these squares? They're not tenths. That would be a whole row. These are hundredths. So we have 30 hundredths. Or, simplified, 3/10. Because we could rearrange all of these squares into 3 nice long rows. But why is it working like that? Why, when we start with 6/10 and we multiply it times 5/10, do we get 3/10 or 30 hundredths, which is less than either of the factors that we started with? What is going on? Well, it's because we started with a group of less than 1. 5/10 is less than 1 whole. And we took 6/10 of that group. So this is a lot like what we did when we were multiplying fractions. We started with less than 1. We're taking 6/10 of it, and 6/10 is less than 1. So it would make sense that our answer would get even smaller. Let's try another one. This time, let's start with 7/10. So shade in vertically with your first color, 7/10. If you want to switch colors up, that's just fine. I'm going to stick with blue and yellow though. And now in this problem, we're going to try to take 3/10 of that 7/10. So get your second color and shade in horizontally 3/10. So when we think of this, we're thinking 3/10 of 7/10. Now what we need to do is see where they overlap, and that'll be our answer. If you counted correctly, you counted 21. 21. 3 times 7 is 21. We have a grid. 3 by 7 is 21. But 21 what? What are these little boxes? They're not tenths. They're too small for that. These are our penny pieces. This is 21 hundredths. Or 0.21. 21 hundredths. So what seems to be the pattern here? Because it'd be really nice not to always have to draw it out and not to always have to count up every little box. So we've made the connection that 3 times 7 is 21. But what about where to place the decimal point? Something to ponder. Go on to your next grid. See if you can color this next one correctly and find the correct answer on your own. See if you can draw this correctly. 8/10 of 9/10. So we have 9/10, and then we're taking 8/10 of that existing 9/10. See if you can draw that out and figure out your answer, and then you can check back with me. Press pause now. All right, so we've got our 9/10, and we've got our 8/10, and where they overlap is going to be that sweet spot. That's where our answer is. So all of these squares, all of these little hundredths, and how many are there? I really don't want to have to count all of them. Well, it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8. Hey, that's like over here, 9 and 8. And I know that 9 times 8 is 72, but 72 what? 72 small boxes. 72 hundredths, or 0.72. So 9 times 8 is 72. So if we're looking for a shortcut so we don't have to draw and color and shade and count every time, it looks like if we multiply our two factors, 8 and 9, we get our 72, but what about those decimals? Okay, you ready for the shortcut now that we can see how it works? So when we're looking at these numbers, what we need to look at is the fact that we've got something that's less than 1, and we're multiplying it by something else that's less than 1. So our answer definitely needs to be less than 1. The interesting thing about this is that since this is the 10ths place, that's like 10 to the negative 1. So when we're talking about powers of 10, each of these is 10 to the negative 1. So how many powers of 10 do we have? We have 10 to the negative 2 powers of 10. And that negative 2 is going to tell us where to move the decimal. Check it out. We have our fast fact, and we have been saying, like, cheat with zeros. Fast fact, place your zeros. Well, we don't have any zeros this time, but zeros are just powers of 10, and we do have powers of 10. In fact, we have negative 2 powers of 10. So that means that instead of placing 2 more zeros and increasing the powers of 10, what we're going to do is we're going to decrease, because this is a negative 2. It's like a withdrawal from your bank account. It's a decrease. So instead of 72 as a whole number, we need to decrease by 1, 2 powers of 10. Yes, that's right, folks. We have a butt cheeks scenario. 1 power of 10, 2 powers of 10, and we place our decimal. So however many powers of 10 we have in our factors is how we're going to end up tweaking that number. And before, we placed zeros over here to increase the powers of 10, but this time we're decreasing because we're using decimals. What about this one? 2/10 times 3/10. Well, let's figure out how many powers of 10 we have. Again, this time happens to be 2 negative powers of 10. So let's do our fast fact, then powers of 10. 2 times 3 is 6, and we have a negative 2 powers of 10. Oh, I've got a gap. What goes in this gap? Well, this means it's going to be 6 hundredths, so we need a 0 in the gap. 2/10 times 3/10 is only 6 little hundredths. Here's some for you to try on your own. Copy these down and see if you can use the patterns that we've learned about to find out the answer. Be careful on number 3. Press pause now. Okay, did you get them right? Number 3 was especially tricky because it was 4 wholes and 2/10 of those 4 wholes. So 4 times 2 is 8, and then we only had 1 power of 10 to deal with, one negative power of 10. So we only moved the decimal 1 place over. All right, here's your task. You probably noticed that you have one 10 by 10 grid left over on your worksheet, and this is for you to make up a problem. So some amount of tenths times some other amount of tenths. You've got to work with tenths for these grids. Color it in, find your answer, and write the answer down as a decimal and a fraction. And be thinking of those powers of 10. Enjoy!